Hi, everyone, and welcome to the W3C WEBRTC Working Group meeting on December 9th, 2025. Next slide. This group abides by the W3C patent policy, and only people and companies listed at this link are allowed to make substantive contributions to the WEBRTC specs. So here, this is the December meeting. We have up on the wiki, you'll see our future meetings. And the dates are January 20th, February 17th, March 24th, and April 21st. Please mark your calendars and let us know if that works. Next slide. We got meeting info for today's meeting. And we have the IRC link there, and we need a scribe. Do we have a scribe?
Yes.
Thank you. Is that Don?
Yes.
Thank you. This meeting operates under the W3C Code of Ethics and Professional Conduct. We're all passionate, so let's keep it cordial and professional. And we'll use the speaker queue in Google Meet. And next slide. Document status. We all know this one, I think. Next slide. And here's the agenda for today. So we will start with Thomas on user media element.
Hi, so it's Thomas and me who are joining. Just quickly an introduction from my side. I'm the PM on the permission element or user media element or geolocation element, depending on which element you want to refer to. And Thomas is also in the call, is the technical lead on this.
Hey, yeah, I'm Thomas on the Chrome teams, focusing mainly on the permission teams and Pepsi project, which involve the permission element over the last few quarters.
Okay, thank you so much for giving us 30 minutes to talk about user media. Mike and Marian, I guess, gave you already an introduction and a good overview about user media. So I will just quickly make a very short intro so we are all remembering what user media is about, and then hopefully we can open for discussion. Yeah, so as said, we want today to discuss the user media element with you, which was previously known as the permission element or the Pepsi element before we have iterated on it. We realized for the permission element that at the end of the day, the user doesn't really care about whether they give permissions or not, but they care whether they can use the capability or not, which is why the permission element got reiterated on it to add a functionality to it to control the capability. So in the case of geolocation, it works very smoothly, right? Like users click on the button, they give permission if permission is not granted yet, otherwise they will basically send the location to the site, or let the site get the location from the user. So this works successfully for location, so that geolocation, so that we can launch this January. So for user media, it was a bit more difficult. So we tried our best to iterate on the permission element, and we iterated actually also with Jan Ivar, who was in this call, on trying to add up functionality to user media to mute, unmute microphone or camera. But we also got feedback from Zoom, Cisco, and Meet that the current proposal is not super compatible and a bit too complex for them to implement and to make it work on how they are currently using mute and unmute camera and microphone. So yeah, at the end of the day, we realized we are not the experts on user media, and we would love to get some input from all of you and ideas on how we can make this user element more than just like controlling permission. Yeah. And I'm not sure whether I have forgotten something. Besides Thomas, we also have Balázs and Daniel in the call, who's also part of the Pepsi or capability element. Then, if you go to the next slide, I put some discussion points on it, but I'm happy to also give more insights or explain a bit more on the use element and the new proposal.
Daniel, you're first in the queue, but you're muted. So
Yes, no, I'm generally supportive of this. I'm just happy to see if we can figure out the details. I think there are a couple of versions of Pepsi. They call it the early version versus the later version are quite different. So we're interested in more of the details where we can use it to trigger muting, where we can have Pepsi buttons that replace existing buttons that are common in the interface. And to get that right, I'm wondering if this working group would need to own the problem, or it can help in any way.
yeah.
Yes, in general, this is interesting. As we said at TPAC, there are still some concerns. While I think that the general approach does not belong to WEBRTC working group, like for instance, styling and so on, which is probably global to geolocation, user media, and other permissions. Things like the interaction of this user media element with device enumeration and various things like that would best be handled in this working group. So I think it would be interesting to know how we can interact and how we can do things, like since it's something like a cross-working group functionality somehow. So it would be good to discuss this as well, at least. I'm not sure we are ready to dive into all the details related to user media element, and I haven't looked precisely as well as the old version and the new version. One concern that I have is that from what I heard, geolocation is permission is about to ship right in Chrome, and for user media, at least, I really want the working group, the WEBRTC working group, to have his take on it before Chrome ships it.
All right, any other comments?
Yes. I see that mute and unmute is added to the scope of the user media element. Can you provide some details about how that works and whether video conferencing applications have provided feedback on it, since you mentioned that it doesn't necessarily adapt to the way they do mute and unmute. So I'd like to know a bit more about that. Yes, Thomas.
I don't know that I have enough time to talk about mute and mute, so maybe giving a link later in the shop, like when people like so when people clicking on the user media element and accept the permission prompt, and I mean we have the granted permissions, and we either click on that, and it will be able to mute and unmute the the media stream letters. So basically we have to gain the permission first, and from that condition, click on that mute, unmute. Let me send the link maybe to the slide. So here we have. Wait. Jennifer?
Yes, so I've been part of the discussion with Andy here a little bit. So I'm happy to provide what I understand to be, or my take on it, I guess, if that is helpful.
Yes, please go ahead, Janiva.
Okay, so yeah, so I think what we were looking at was, well, what we didn't like was that there's these priming prompts. There are two ways to use Pepsi. You can have the application put up basically what looks like a permission dialog and create a quote-unquote fake permission dialog ahead of the real one. And we don't think that's that useful because it just adds more prompts. So for there to be a savings in number of clicks, the goal was to find a way, can we replace some buttons that are already there and basically have them work as first-class access buttons to the actual resource, not just to toggle permission on and off. So to do that, we recognize that video conferencing sites generally use these as toggles to mute or unmute the local track using track enabled equals true and false. So it's a little confusing to talk about mute because in WebRTC there's also the track muted state, which is so quickly the enabled state is up to the JavaScript application, whereas the muted state is up to the user agent. So there were two proposals there. I think first we proposed that it would actually, when you hit this button, the user agent would actually mute, which is a stricter state in that the JavaScript application can't necessarily easily unmute. And this would be cleaner to implement and grant users some extra protection, privacy protection, so when things are actually muted with this button, they can be assured that the website can't hear them. Of course, that's a double-edged sword because at the same, that's not necessarily how websites are muting today. They're using track enabled disabled, which is much more, can be, it means they can still listen to the user's microphone to see if they're speaking and then ask them, did you want to unmute? Things like that, which has now been made available in the media session API. There's a way to actually request for that, but that is a new API that hasn't been broadly implemented yet. And of course, we're also talking about an element that we want web applications to voluntarily put on their page. And they could easily, if we don't get this right, if this is too restrictive and web developers don't want this feature, they could easily then flip out and, not flip out, sorry. They could flip out, but also then they could switch out the Pepsi element with a regular toggle. So I think we're open to looking at both ways. So it's not settled yet how exactly we would mute and unmute, I guess. Min?
Thank you, Janiva. This was a good summary of what we have discussed. Just referring to two things you said. The first one, I think you're referring to sharing with the group. Can you see it actually? Yeah. You're referring to this prompt, right? When you're saying the button was put into a prompt.
Yes.
Yeah. So here in Zoom or Meet, both have this kind of like pre-prompt, which was already there independent of the permission element, the Pepsi element. They always kind of had a pre-prompt to give the user some context why they want access to camera or microphone. And the difference is back then the image had a person kind of pointing to the top being like, you have to accept here, while here they put the button into the prompt. They have the opportunity also just to put the button basically here right? And skipping the pre-prompt, but it's more like a decision based on the conferencing website, whether they have this pre-prompt or not. So just like some context on this one. And I think the second one, what did you say? But I think I forgot now. So I was just like, let Johan add your thoughts to it first.
One thing you mentioned, the person that was pointing up in the corner, that wasn't actually a prompt so much as an indicator to say that the browser prompt is up here. So that means you would click once, not twice. But other than that, I agree.
Mm-hmm.
And I'm not sure what the second point was either. Sorry.
No, if I remember, I will come back to it. So to Yuan.
So specifically for mute and unmute, so MediaStation is solving this issue. Basically, you have a way to mute and unmute with the MediaStation API, and muting can be done without a user gesture, and unmuting can be done with a user gesture. It's implemented. So if it gets integrated with Pepsi, the main difference between Pepsi unmuting and the current MediaStation unmuting would be that in one case, the web page needs to call the API within a user click, and the user click can be in anything, really, in any web page. While with Pepsi, it will be on a button with some constraints. In general, so when we discussed this at the MediaStation level, it was thought that since the user granted permission for that web page, then muting was okay in any case, and unmuting with just a user gesture was kind of okay because the user previously granted permission for that web page. So it was kind of okay. The main thing we want to prevent is if a web page tries to unmute when it's hidden or anything like that. So we can discuss that. That's interesting. The main pain point that I see in cameras and microphone usage on the web currently is the first permission, when a permission is asked the first time, and the device speakers. Device enumeration is a pain point in web pages because it's done differently in different browsers, and that's something that maybe Pepsi could help as well. So that's one thing I wanted to mention there.
Yes, I would agree about device selection as well. I think having a button gives browsers a convenient place where they could entertain having device selection quite early, and not even needing enumerate devices potentially. But I think that's more of a long-term benefit of this direction.
I was thinking short-term. A short-term solution, meaning it's not clear to me whether the user media element is actually requesting permission and starting to capture right away, or whether with user media element you can request permission, but you will start capture a little bit later on. And if so, where the exposure of devices happen in all these cases. So these are some details that we could try to discuss at some point, I think.
Well, from my perspective, it's just equivalent to calling get user media to that point. I would not want it to just be about permission. So the goal would be that this is the button that you obtain the stream with. And I believe that's the direction we're going.
Okay, so there's so the closest we have currently that would be similar to Pepsi is if websites would call get user media synchronously with a user click, I guess. Okay, then it's good to do some comparison between current behaviors in browsers with Pepsi and with Get User Media being called with a user gesture. Because at least Safari's behavior when Get User Media is called from user gesture is slightly different in terms of prompting and things like that.
So other feedback we've given as well is that we would love for the element to be called, this is bike shedding, but camera and microphone elements, instead of the user media type equals, because that's sort of the input field problem again, but that's just bike shedding. Guido?
But if you make them separate, then what if you want to call both at the same time, which is pretty common, like Get User Media, audio through, video through?
Well, we could entertain having a user media element for that case. My argument for having a separate is that, you know, creating new types is cheap and from an implementation perspective, and end users, making sure end users have clearly defined concepts, I think wins out as far from a usability point of view anyway.
Okay, so your proposal will be 3 elements, no? Okay.
Yes, I mean, there are 3 here anyway, because there's a user media element with different types. There's a type field that would sort of hide that there are very different behaviors, very different API surfaces, very different styling for 3 potential cases: camera, microphone, and camera plus microphone. In fact, it's not really clear, yeah, how a toggle with both camera and microphone. I mean, we can all imagine how that would work, but it doesn't really exist on the web. Dom?
Yeah, so without diving more into the technical detail on naming and so on, I think a key thing we should discuss is how we would split the work to make sure the work can continue well. I mean, there was discussion earlier that WEBRTC working group might need to keep ownership of some aspect of this. So I wonder if there are already well-defined hooks in the Pepsi approach that could help us organize this split.
Min, do you have an answer to that?
You're muted. You're muted, Min.
No, I said, sorry, actually the last part was cut out, so I didn't understood the question. Can you repeat? Maybe I can answer it, but I have a different comment.
Yeah, I was wondering how we can split the work between WebRTC and WebAppSec. As Yuan and Yaniva were alluding, there are aspects of relationship to device enumeration and privacy consideration and so on that I think this working group is best positioned to deal with. But conversely, you all have a lot more of the background and the Pepsi framework overall you can take care. So are there hooks in Pepsi that could help us determine who's doing what, or is that still something we need to dig deeper asynchronously?
It was a bit hard for me to understand because I think there's echo, but is the summary of the question how we should move forward together as the group and the permission team?
Yes, essentially.
Okay, perfect, because it was exactly my question. Or I would say we are very open to meet more regularly, maybe outside of this group, or have a workshop day to kind of like find a great solution that user would love and developers would love to implement as well. I saw Jason is in the call, who's from Meet, who can also, I guess, join this kind of workshop to represent what conferencing side might need. But I'm very open, and since this is the first time me working with the WebRTC, I would be open to the time you would give us.
That looks good. So in the past, the closest we had, the closest default that we had was permissions. There was the permission stack, and then there was permissions integration of camera and microphone. And this part was in the WEBRTC working group and is integrated in the media capture spec, for instance. So I was wondering whether something similar could be done, meaning like a main spec and maybe extensions dedicated to camera and microphone, either in media capture main spec or media capture extensions or its own sub-spec. Something like that. So do you have any thoughts there? Or are you okay with it? Or is it something like you would prefer iterating on your own first with user media element?
We haven't thought much about it, also because
Okay.
I just hope it's the first time we're working. So if there's a recommendation from your side, we are happy to lean on that. But in general, we would love to collaborate because we, like from our side, we just know more about permissions than about the user media element.
Okay. Yeah, I would tend to think that if we can do like for permission spec, it's a nice model. When we discussed this with Dom, I think there's no issue with the charter, so there's no administrative issue, I guess, of doing some work related to the user media element in the WebRTC working group. So that's something I would tend to do. And also, since you mentioned that there are some mid developers in the room, it's good to have developers anyway in the WebRTC working group, whether for user media specifically or for other stuff as well. So it would be also a bonus, I guess. What do you think, Jan-Ivar and Guido?
That works for me.
Yeah, that works for me too.
All right, so I'm hearing the working group will take on and discuss and try to integrate advice for Pepsi along the lines of what we've done for permissions in the past. Is that
Yep.
Is that fair?
Yeah. I think it's fair. I guess media capture extensions or its own spec. We can discuss this later on, but I think that's the first summary.
Yeah, I think we can do media capture extensions if that works. So we try to deliver a permission or a Pepsi integration section, I guess. And that would let us continue these discussions.
Go ahead, Min.
Sorry, I forgot to put my hands up first. I know this is a more practical question, probably more PM question. So from a practical point of view, this user media or permission element, as was before, is running as an OT for a while now. Like, I think we extended for 4 times already. And obviously an OT state is not a state we would love to stay in, especially if we already have like Zoom, Meet, and Cisco using it. Can you imagine, and it's just an open question, whether we can see an MVP of the user element that it works like it's currently working today, with maybe some degree of freedom we can add to it, so it will be easier later on to extend it, and yeah, launch an MVP to get out of the OT state, which is probably better for most of the conferencing website, and iterate on it then. Because otherwise we might need to just keep asking for OT extensions continuously. I mean, it's not a answer today, but I just want the room and for us or for you to discuss. Yes.
Yeah. In general, this working group has a track of APIs shipping in one browser, and then it's hard to get them in the other browser. And what we're trying here is to do as much of the specification we can do before one browser is shipping it. This way, it will be much easier for other browsers to implement it as well. So I cannot give any idea on schedule, but what I can say is that we should allocate as much time as needed to work on that, and that's part of the spirit of having this conversation now.
Yeah, I would share that sentiment. I think the Mozilla position on the original PEP-C was negative, and I think my engagement has been to try to get that to be positive based on changes. And so I would think it would be unfortunate, unless I'm mistaken, what would ship in this case sounds like closer to the 1.0 version that we have a negative position on. So I don't think I would be in favor of that. So I think I would love to spend some time to make sure this is interoperable.
So maybe one way to think about this is what would be the MVP you're thinking of? I mean, because again, there are lots of details that will need to be figured out. Understanding which of those can be left for later is itself not necessarily very easy. So, like, I don't know if you have a clear picture of what an shippable MVP would be for you, then that can help maybe focus the conversation of the working group to get there sooner rather than later. But yeah, in terms of interop, I think something that ships too early, as I've said, tend to create challenges for real interop down the line.
Come in, and you're at time, so.
You said we are out of time, or should I reply?
Go ahead.
Oh, so just my short answer. We don't have a concrete plan yet how this could look like. This is also something I just wanted to suggest, in the sense that if we come up with a plan, or if once we discuss more and get more insights into this, maybe we can bucket them into steps and being like, okay, this could be MVP. We can change the element in a way that it's flexible enough to add more functionality over time. So, you know, backward compatible and all this kind of stuff, but good enough for an MVP. So it doesn't have to be the state it is today. So it should iterate and be more flexible, but maybe we can find a good MVP version. Yeah, Janiva.
So for me, I think MVP would be buttons that are used as toggles, basically the buttons we see at the bottom in this call for camera and microphone. And I think we're also flexible on styling, maybe loosening some of the styling requirements in order to get websites to use them. That would be, I think, agreeable to us to some extent.
Well, we have to move on to our next topic. So I guess Dom has got the action items in the minutes.
So I have as a resolution, use media capture and stream or an extension of it to provide the PEP-C integration section of an anchor for further discussions.
Yeah, and we continue the discussion on how to make that happen. So let's move on to the next topic. The data channel close event.
Yep.
John?
Sure. So we are talking about new stuff. Now we will go back to old stuff. So as per spec, and since quite some time, when closing a peer connection, it's expected for local data channel objects to go to closed state, but no close event will be fired. I guess that if you follow the link there, the JS fiddle, you will see that Chrome is firing the close event, Firefox is firing the close event, and Safari is not. So only Safari is following the spec. And the question is really, should we update the spec or should we update Chrome and Firefox instead? So do we have a use case for changing the spec, basically? Next slide. The first thing is that web developers are hitting this issue. So it's a real interop issue. And probably people can work around them, but still it's bad. So we really need to take a decision there. So the web developer that filed this Bugzilla issue mentioned that in the application, the data channel object is well used as a WebSocket object. So you send message, you receive messages. And one part of the application is managing peer connection, and another part is getting these WebSocket-like objects and doing stuff. And they're not the same parts, and they're not really connected a lot. So sometimes the first part will close the peer connection, and then the second part will not know it without doing some additional coding. And that's where they have this issue. The second thing is also that data channels may live in workers. So you can create a peer connection, then send it in the worker, then in the window environment, you close the peer connection, and the data channel would then go to closed state without a close event, which seems also a bit odd. I don't think that we actually, when we define transform data channels, we did not really think about this case. So based on that, my proposal is to align the spec to Chrome and Firefox behavior, write a WP test, fix Safari. We might want to update the spec to have like to identify how data channels are closed when they're in a worker as well. Probably it's fine, but we still need to do things properly. And also, if we all agree with this, I wonder whether the general rule of when you stop an object, you try to not trigger events for that object. But when you stop an object and one of its child could fire an event, we say, hey, my state has changed, then maybe we should actually fire events there, or at least we should not block it. Thoughts? Yep, Harold.
I like the general rule and I like the special rule. The only question is, in the spec, should we post the task to fire the events, or should we just fire the events inline? I think we should post the task, but I'm not sure.
I don't know. I would look at what Chrome and I haven't looked at what Chrome and Firefox are doing there. The issue is that I guess if you post a task, you should update the state in the task and not synchronously when calling peer connection close. So
Yep.
that's the thing I don't know. But ideally, yeah, we should queue a task.
Yeah, so I agree with aligning with implementations. I don't know if we need to actually agree on a general rule, but it sounds nice.
Okay, sounds good. Is there anybody else, or we can move on maybe?
No.
Okay, sounds good.
Just quickly on the
Yeah.
general rule, I wonder if it would be worth submitting it to the tag for the design principle. That way they can say whether they think that's indeed something generally applicable.
So we could take some time to know whether there are other APIs which have the same kind of close one object and some other objects get closed or not. Maybe web transport. I'm not sure. Yeah, I'll find an issue specifically for that and mention that there is consensus within the WEBRTC working group, and then we can discuss whether how to preserve this knowledge somehow, whether it should be the tag or somewhere else.
Okay, so we can move on to our next topic. Media capture transfer, track transfer feedback. So I'll take care of that. So basically the media capture transfer spec is currently written around media stream track transfer. So to create a media stream track processor in a worker, it is necessary to first transfer the track to be processed to that worker. And the track must remain the worker in order to deliver frames to the processor. And also, the track generated by a video track generator is created in a worker, and then it must be transferred to the window in order to connect it to a sync. So I'm going to talk about feedback that we have received from developers regarding this issue. And like the main issue is that it's impossible to use, once you transfer the track to the worker, it's impossible to use the track with any sync outside that worker, including even using another media stream track processor in another worker. So all the interaction of the application with the track then require message passing to and from the worker. And one proposal to mitigate these issues is a polyfill that Geneva made a sketch of, like a generalizable polyfill that basically clones the original track, transfer the clone to the worker, and then the original track is augmented so that its operations pass messages to the worker behind the scenes to communicate with the clone, so that the clone and the original track keep their state synchronized, and that is the link to the utility. But then we presented this to some developers, and we have observed that augmented track, it doesn't behave the same as the original track, which is a problem because normally what the applications do is that they pass the track to multiple modules. The modules are not necessarily aware of each other, and then if one module is the one who's going to use the stream track processor, then the track will be augmented for everyone, and then it will start working differently. And the biggest concern is with the operations that are synchronous in the API, but then become asynchronous, especially stop and enable false, which are operations that have privacy implications. So you can have a situation where you stopped, and you believe that the stop is synchronous, but of course, what you did was to send a message to a worker, and the track, the source is still alive, and it's still delivering frames to the processor, and then the application, that module might still be working as if the track is alive, and for example, sending frames to the network or wherever. So what the polyfill does is that it introduces two APIs, the original and the augmented one, and it's yeah, this duality makes it's a practical, it's in practice an impediment for a complex application to adopt this approach. Another issue, more generally, is that the problem that the polyfill is trying to solve is quite complex, which is the strong consistency of multiple replicas. Those clones are strong references, unlike, say, a handle or a pointer, so that they keep the source open as long as they're alive, and they keep delivering frames as long as they are enabled. So the augmented track needs to keep track of all the clones sent to different workers if you want to use different workers, which is some developers do that, and then you need to implement a protocol to make sure that everything actually occurs in a synchronized way. This also applies to apply constraints, although apply constraints is asynchronous, so it doesn't change as radically as the other two operations. But the problem is that this message passing is not necessarily 100% reliable, which is another complication. Because, for example, a busy worker with too many messages can keep a message in the queue for longer than expected. It could even drop it. The implementation might even drop it if it's too loaded. The message passing can also fail, say if there are unhandled exceptions because the worker could die. There are a lot of issues to work around there. So, and fixing those normally requires complex algorithms, typically like a strong consistency in the presence of failures, of partial failures, typically distributed algorithms. So all this complexity just to work around the issue that you need to transfer when we can fix it in the API is just unacceptable for applications just to work around this deficiency in the API, especially when we can fix it with patterns that we have or we are already using in similar APIs in the web platform. And in regards to video track generator, so the situation is that the track is creating the worker. The track is generally useless there because there are no other things other than the mainstream track processor. But in this case, the mainstream track processor is not useful. So applications always need to transfer the track to the window to do anything useful with it. So this means that the track is always creating the wrong realm. The consequences are not as severe as with the case mainstream track processor. It's mainly that we're forcing some boilerplate in applications, but at least with the generator, the issue is well understood and easy to work around. You just transfer it. You just have to always transfer it. So it's not a hard impediment for applications to use the API, as is the case with the processor. But still, it would be nice to fix it by creating the track in the correct realm in the first place. Also, and this doesn't go to applications, more complexity for browser implementation because now they need to support track transfer prior to supporting video track generator. And yes, and in addition to developer feedback, Dialpad also provided some feedback in the GitHub issue. Basically, they say, well, they provide several details, but I highlighted the most important parts, that they prefer to have a single track and retaining ownership of it in the main window, because that helps simplify the process of applying constraints. And also, the mainstream track operations are done in the application whether the use case requires the worker or not, so they prefer to the operations to be done in the same fashion in both cases. So, that's it. So, shall we discuss anything, or should we move on directly to Juan's proposal to try to fix this and then do the discussion at the end of that?
didn't want to listen.
Harold is on the queue.
Okay, John.
No,
Huh?
I'm not.
Oh, no, Harold. Oh, no, you're not.
No.
Okay.
And that was a mistake.
Yeah, from the, okay.
Oh, okay.
Oh, John.
I don't know. It's really up to you. I have some questions there, so maybe I can ask them first. So you mentioned that stopping tracks synchronously. So basically, it would be done async.
Yes.
With so that I don't really. So I guess it's in the case where you have like a track and you're doing like you have a track for
what I
camera
mean-
and then you're doing like a transform like background blur, like whatever, and you have another track. So you have two tracks, the camera and the transform one. And then what you have to do if you stop the camera track is to stop the transform track synchronously, and ditto for enabled. So I'm not sure I understand why there's this issue about synchronicity in one case and
I mean,
not the other.
the stop operation is a synchronous operation. The purpose of the shim is to hide the fact that there is a clone, that the application is not really interested in the clone, it's only interested in the main track. It's just to work around the fact that you need to transfer it because you want to keep controlling the track on the window so that it integrates nicely with the rest of the application. The stop operation is synchronous. So it disconnects the track from the syncs synchronously.
Yeah, and I understand that, but in practice, though, when you're doing your
practice applications want to be able to stop the track and trust that the track is actually stopped. Not that you send a message and then that it will eventually be closed and you never know when. Yeah. So you would need to augment the API so that stop is asynchronous, to have a promise say so that when the promise is solved, you know that all the clones were actually stopped.
Okay, so that's really that. That's not like because the case of hey, some video frame might slip and so on. That's there's no issue with this. At least I don't understand the issue with this. I think in the slides it was mentioned.
I mean, you're managing your tracks in your application, which has 10 modules, and two of them create replicas. Two of them create these hidden clones to some workers, and one of those workers sends the data to the network, and then you say, okay, I want to stop the track. So the track is stopped for all modules, but it's not stopped for the clones because you have to wait for the message to get there.
I don't think that there's any, except in the case where what you said post messaging is actually happening, is very busy and so on. I don't think that there's any.
You have to work around that. I mean, these are highly loaded applications.
Let me finish. Let me finish.
It's asynchronous.
What I'm mentioning is that in current comms implementation, where processing happens in a worker, you stop the track, and then in the worker, video frames will still be provided for some short amount of time because they're in the pipe. Because you have the video frames that are flowing in some thread, they're hopping to the worker thread, and so some video frames will, of course, be processed after after the track is stopped, which is fine, and we cannot really solve this very, very, very easily. So in this case, what you're saying is that since you have to do post message, then there's more latency than what could be done with a native implementation.
There's not only more latency; it's that you're actually still connected to you're actually. Well, you could. I mean, that you could say it that way, but normally, once you do stop, you know that the track is no longer connected to any sync. So the track is not delivering any frames to any sync after that point. It's that if there was a sync in flight at that in another thread at that point, okay, that's something that can happen, but
Yeah.
but this doesn't guarantee anything. I mean, it's not even 100% guaranteed that the message will make it to the cloud. So,
Well, that's not something that I saw in Safari. I don't
well,
see how
you
messages
could,
can be.
you could argue that yeah, that it's possible to have an implementation that never drops a message, but there are issues there. And this is just a huge complex workaround for something that we should fix in the API, and dealing with these clones is just too much to work around that effect in the API. So go
Okay,
ahead.
go ahead.
No, just make sure everyone gets time to speak. So that's why we have the queue. So, Yuan, did you get to make your point?
Yeah, I think so.
Okay, I would agree with Yuan here that I hope we don't have any. I don't hope people don't have code that relies on stop being synchronous, because it seems to me that even the case that Yuan mentioned, if you have with readable and writable streams, you can have frames queued already. So the fact that you stop the track doesn't mean that there aren't frames in the queue. And if you wanted to make sure that those didn't, if you wanted to wait until those had gone through, you would need to contact the worker and do a post message back and forth round trip anyway.
Well, we have a lot of code that relies on enable equal false.
Sorry, enables what?
Enable equal false to disabling the track.
That's the same there.
Well, so yeah, you click disable and then you're still sending.
But the result of the stop is not on main thread; it's on the media thread, if you will. So, and also the piping setup of streams means that there are queues and buffers downstream. So if you want to make sure that frames don't appear after you stopped, you have more work to do, regardless of this polyfill or not. And so the point I want to make was that I said before is that with workers, there's basically 3 ways to get things to and from a worker. It's post message, transferable streams, and RTC RTP script transform. That means that the rest of the web platform has managed to do with the first 2, and this working group is not satisfied with what the rest of the web platform has been doing for workers. So we've invented one new API, and we're talking about inventing another. And I don't actually think it's this complicated.
I mean, that's far simpler than this polyfill, and we have it in the field working for quite a long time without any issues. And that pattern, by the way, is the same used by other worklet. It's just that it's done with a worklet, not with the worker. But you add the module in the in main, and then the code starts working in the worklet. So it's not for processing media. We have at least 2 APIs that do that. That the action to create the processing is in the window, and then the processing run gets the processing objects on their side. And the feedback for developers is clear. I mean, there's an impediment for some applications, and the feedback is that all developers prefer to keep the original track and handle a single track that they own on the window, and it's super easy to fix this in the spec. There are several different ways that we can do. Yuan is going to speak about one, and it's something that we should fix, and it's as simple as that.
Well, I wanted to push back on the claims that there were synchronous needs that were not met by the polyfill. I think this isn't hard to fix the polyfill exposes a callback method that you can use to post message to any number of clones. It doesn't actually clone itself. It's merely just a wrapper around a native track that allows you to post message wherever you want. So it's a very neat little tool. So I don't think this is necessary. So I think, but I think we also are running out of time here. So, Ewan, did you want to discuss here?
Yeah, I can understand for very, very complex applications that sometimes when you have a track and you want to hold to it, then you might only want to take the pain of replacing a track with another one, because that's basically what we are dealing with here. In practice, though, capture fails, and you have to call get user media again, and you have to replace tracks. So web applications have a way to replace tracks dynamically as well. So that's why I'm really on the fence here, because I think it can be it is a problem that is solved today by web applications that are robust enough to capture failure.
Yeah,
But it's true that it's not as good as, it's not as simple as what people would like. That I agree.
Yeah, and also I'd like to point out that you say, okay, that this can be a problem for very complex applications. Well, we went to the trouble of making this worker first for those complex applications. Because applications that are not very complex don't even need the worker. So we made this API complex for complex applications, but then it's very complicated for complex applications to use it because we introduced these hard requirements. So this is something that it's super easy to fix, and we should just fix it.
So I think the problem we have is that the whole working group did agree on this API years ago, and it was shipped.
That doesn't mean that it's written in stone. This is just a working draft, and working drafts are subject to be modified based on feedback from the field, and the feedback is you have two feedback.
Okay.
Feedback from developers saying that this is an impediment for them to use it. And you have feedback from one implementer who, when we were trying to implement it, we said, okay, no, this is really bad, so we're not going to implement it. So we have changed the user media, we have changed the number of devices, we have changed applications that have been, APIs that have been widely deployed, that are at a more...
I sympathize. I sympathize. I sympathize with the web developers in this current situation, because you have different browsers implementing different APIs that aren't inherently compatible. So it is complicated right now. That's also why it's really hard to judge whether this problem, this lack of adopting the spec here, is that really because of the problem with transferring tracks, or is it something else? I think it's really that it's hard to judge. Well, because we don't have good implementations.
I'm telling you officially that Chrome will not implement this because it's a bad API. It's a bad API to force the transfer requirement, and that's the opinion of Chrome, the official opinion of Chrome. So that's the reason why Chrome will not implement it. Not even if we implement transfer track, we will not implement this API. Not even if we implement track transfer, because this API is so broken that we will not propose this to be the interoperable solution. So we really need to fix this.
I mean,
if we want interoperability, otherwise we can just add yet another note into the spec saying that there's no consensus in the working group about that point.
Yeah, I mean, without considering the questions around implementation instances, I think the request had been, can we get feedback from developers on the API shape? I mean, Guido did the job. I think the feedback is pretty darling. So, you know, at some point if we are asking developers feedback, we should be ready to listen to the feedback from their perspective.
I think we are acutely aware that it would be bad for. Sorry, I should have raised hands. Harold's first.
Yeah, Harold. Yeah.
So speaking of the thing that happened years ago, no, we didn't have consensus. We put up an experiment to figure out if this was a go, and the idea that MSTP only has to live in a worker didn't have consensus at the time. The idea that media stream track transfer was a requirement for using this as a worker was not a consensus at the time. Frankly, one implementer wanted this, and one no feedback was had from developers. It got implemented, something different got implemented, and frankly, arguing with past consensus is neither truthful nor useful. So can we please do what developers want to use as warranted by the feedback we've had on this one?
So my feedback here is that we are listening, and we understand that it's really important to get Chrome on board in order for this API to work. So I think we're willing to make compromises.
Good. Okay. Well, let the minutes reflect that, and then I guess we can move on to the next topic, which is still related to this. So.
It is. Okay.
Very much so. That's one solution, right?
Yep. So from what we discussed, we want to allow processing media stream track data in a worker because that's where real-time or semi-real-time processing should be done ideally. And some web applications are doing that, but they express the desire to keep media stream track API control in a window environment, and that's that's fair. At the same time, we have an API that is existing in implementations and in specs, and we want to limit the complexity and the API surface as well. So in total, there have been 3 identified approaches. At least we identified 3. There may be more. Clone-based GSFIM, RTC encoded transform-like API, and handle-based approach. So we'll look at the handle-based approach here and compare it with clone-based GSFIM and encoded transform-like API. Next slide. So basically, on the left, there is an example of how the API would look like, and on the right, the WebIDL API. So there would be a new interface called Media Stream Track Handle that you can construct from a Media Stream Track. And this handle is exposed in window dedicated worker and is transferable, meaning that you can post message it from window to a worker. As long as you keep the handle alive, then it means that the track is kept alive as well. And the additional thing that is done here is that Media Stream Track Processor constructor is having a dictionary that is taking a track. So in this case, we would extend it to take either a track or a handle. So you can see code there where we are constructing a stream and we are adding the track. We are sending it over the network, and we want to do some video analytics. So what we are doing is that we are creating a handle by calling Media Stream Track Handle constructor. We are post messaging it, and then the worker will send events back to the window, and we will call process video analytic on it. On the worker context, the thing you have to do is to construct the processor, the Media Stream Track processor from the handle, and then you have a stream of video frames, and you do your stuff there. Next slide. So the past example was done and was focusing on analytics, so processing data. Here I'm comparing with the transform, meaning that you have a track and you want to do background blur, typically. So with media stream track handle, the thing you have to do is to post message the handle, and then in the worker, you create the media stream track processor, you create a video track generator, and then you transform the video frames and you pipe them to video track generator. And in parallel to that, you post message back the video track generator track to the window. So which means that you have to do a wait for track to get the new track. So there's some level of asynchronicity here between the start of the hey, I want to transform the track and the actual access to the new track that is having the transform frames. If you look at the GS shim, basically it's very similar. You include your mirror track shim, and then what you do, you post message the mirror track, and you await again for the track using based on video track generator transfer track. So it's not that different. It's a little bit simpler. So if you go to next slide, I think I have, yeah. So if we do a comparison with clone-based GS shim, it's the exact same feature set. Handle is mostly shimmable, but removes the need of window to worker synchronization, like end track enabled apply constraints, which were the thing Guido mentioned. This would be fixed. There's the automated GC reference, which is a benefit and a risk, of course. If you keep the handle and you lose the track in window, then you will never GC the track. Good practice should always be to stop a track and not rely on GC to stop capture. So hopefully it's not a big risk, but that's still something that needs to be mentioned. Compared to the GS shim, it's exactly the same feature sets, meaning that we are not exposing more API than we need to replace the shim. If we go to next slide, with the with the encoded transform API. So on the left is the exact same script. On the right is I think it's Guido's proposal, at least the one I found on GitHub. I didn't look at the latest version of in the GitHub issue. I didn't look at whether Guido updated the proposal. So you can see that it's there are less lines, basically. Compared to the media stream track handle, you do not have to post message back the video track generator, which means that you get synchronously a new track compared to media stream track handle, where you have to rely on post message, which means that it's async. Other than that, it's not that different. What we can see though is that in terms of API surface, it's a bit bigger. You have like a new method on media devices. You have the on-capture transform. You have the capture transform event and so on. Next slide. Probably I said that. Yeah. So compared to RTC encoded transform like API, it's roughly the same feature set, but the proposal is focusing on read-only processing. While with encoded transform like API, you would need to use that API for both read-only processing and transform processing. like for analytics, the WEBRTC encoded transform like API is a bit odd because you have a track and you have a writable. So I don't think it's asking for the analytic case, and it seems good to have like one thing for processing and one thing for generation. Compared to the WEBRTC encoded transform like API, I think the API surface is reduced. So that means that for browsers that implemented the existing APIs, it's easier and it's less work. There's the major difference, I think, is that in one case, the creation of a transform track is synchronous with the encoded transform like API and is async with midstream track handle. At least that's what I saw on GitHub. Honestly, I don't think it's a big difference, but we can discuss. Next slide. So the question, so is it good enough and is it worth it? These are my questions to you. Yeah, Guido.
So the answer to worth it, yes. The answer to good enough, maybe. So this would definitely address the developer concern. So this will solve the issue of cracks being sources staying alive, and because we cannot disable them or stop them, and would make things a lot easier for developers. So this is definitely something in the right direction. So we can discuss a little bit, especially some things we said about the GC and handling. So in my view, I think this should be a weak reference, so that if the track is alive, the handle shouldn't keep the track alive. But that's not so much. That's not really that important. The important thing is if it's stopped. I mean, if it's ended or not. So we can probably discuss those are details that are relatively minor. I think that the bad thing about this is that it's exposing an object like the script transform approach. I mean, you have a script transform, then you would have a script transform handle, and then send the handle, and you create a transformer there. So
yeah, maybe you should have done that.
I don't think we should have done that. I think it's better the script transform approach, because you don't need to expose an object there. Is there, and then you lose the ability to optimize the operation, because you have to go to create an object, expose it on the web platform, use the exact transfer algorithms in the web platform, and then the nice thing about the script transform is that everything can be significantly optimized. So that's why I prefer that approach. And since that approach is implemented in browsers, I guess it will be easy for all implementations to just replicate that pattern. But I think it's a step in the right direction. Maybe we could compromise on that. So for the two answers, worth it, yes. Good enough, maybe. Probably. In terms of achieving interoperability, I mean, we could agree to this, and eventually we will achieve interoperability once we ship the track transfer for the video track generator. So the concern with video track generator is not so much applications. It's just that it will delay the Chrome implementation, but it's not something that developers. It's a blocker for developers to use APIs. The processor, yeah, is a blocker. So yeah, that's our initial position regarding this proposal.
So if I summarize, with MediaStream track handled, at some point you would be okay implementing video track generator in Worker and media stream track processor as specified in Worker as well, and media stream track transfer from Worker to window, meaning that we would get interrupt.
Eventually.
Eventually. Okay. Yeah, Harold?
Yeah, so one of the problems with media stream track transfer was that it exposed a very big surface, and a lot of functions on that surface we didn't have good answers for, as we're showing up now. I warned you. In one way, the media stream track handle proposal is kind of a middle ground. It exposes a little more surface than the encoder transform lookalike. The encoder transform lookalike basically exposes two streams and no new API. Well, media stream track handle, I can guarantee you that someone will ask to have, for instance, the closed state as an attribute of media stream track handle.
Or you can get it from media stream track processors, so it's it's shippable.
So as Guido says, media stream track handle is slightly more complex, slightly more exposed API service than the encoded transform type.
Slightly more, slightly less. I'm not sure to understand. You're saying that it's
more because it exposes a handle, whereas with the script transform doesn't expose anything. Everything is behind the scenes.
Yeah, it's a new object, so you have to decide. Okay, what's the lifetime of this object? What happens when does it disappear? When does it stop? When does it? And can it be transferred to a third environment? All those questions have to be addressed.
I disagree with this evaluation that it's more API. I think it's less API, but we can agree to disagree, I guess.
Yeah, we kind of evaluate the bigness of
it. So that's why I'm saying, is it good enough? I mean, we can iterate on that question, but is it worth it? Yes. I mean, this is definitely a step because this addresses the developer concern.
Yeah.
Okay.
So you have a solution. And having a solution is better than having no solution. So
yes. Sorry.
Sure. Go ahead, Harold.
No, I'm done.
Okay. Yonivar, do you have thoughts?
Yeah, my thoughts is that it is redundant, but of the proposed solutions, it does seem to be the cleanest one.
Okay. And from an implementer's point of view, you would be okay implementing it as well.
I believe so. I have to check with the team. Just so we're clear, though, there's no support for. I think I would be opposed to the handle is just for getting from the main thread to Worker, right? Not the other way around.
You cannot. Yeah, it is, but there's no use.
Right.
Yeah, you cannot say. You cannot say, hey, it's transferable, but only from window to Worker.
No, but I'd be opposed to source object support for track handle.
Yeah, no, that's not. That's not the plan. Yeah.
Okay.
That's why it's designed this way. The only usage currently it's media stream track processor.
Because it's important to me that all the browsers still implement track transfer. Otherwise, this doesn't work.
Okay. So I guess the plan would be then to write a PR in media capture extension. And
I think you can write it directly in media capture transform.
Oh, media capture transform. Yeah, either one. Yeah. Okay. and then we can start from here. I was wondering whether we should have a call for consensus once it lands. We've done that for media capture transform, but it was not.
I mean, we keep changing. We haven't done calls for consensus for enumerate devices, get user media, but we have changed a lot of times since the last time.
Yeah, but
I mean, we can.
I think.
Well,
I'm
we
wondering
can make
whether-
another one since we have withdrawn our supposed consensus, although the spec has a lot of things that marks that says that there are no consensus. So I guess we can make a call for consensus when we solve the issue with audio and with this. So I wouldn't be opposed to saying in a call for consensus that we finally have consensus.
Okay. Yeah, sure. Then I'll probably start a PR, and we can work from there.
Okay. So shall we move to the next topic, which is audio feedback? Yeah, also from TPAC. So basically, the question is audio support necessary? Which is an issue open from a long time ago, and basically, well, from TPAC, there were several action items. One was to evaluate the performance of the polyfills that Jennifer has proposed to shim missing track processor and generator, and to also get developer feedback. And so, well, we're discussing this because, well, it has been argued that audio support in media capture transform is not necessary because it's redundant with audio worklet. It can be polyfilled on top of audio worklet. And those polyfills are claimed to have decent or even zero performance penalty with respect to native version of mainstream track processor and generator for audio. So to describe what the mainstream, let's start with mainstream track processor. The polyfill uses message passing and a queue where you read audio from web audio, post it to the worker, and then the mainstream track processor pulls from the worker, and it introduces the samples in the readable stream. And this approach makes it possible to support the mainstream track processor processing use cases. But what we observed is that it comes with a non-trivial performance penalty. But the shim works. Of course, we will need to modify it to use it in the worker. But the way it's written is to support on window, and it does work to support the mainstream track processor processing use case. But maybe the performance can be improved if you use a shared array buffer. But anyway, shared array buffer is not always available, so a non-shared array buffer basis needs to be provided anyway. In terms of functionality, the main thing missing from this approach is that timestamps are not preserved, and there are some use cases that use the timestamps like or potential metadata that could be present in audio data objects. So some use cases like delay measurements or AV sync. So here are links to a couple of demos that use the mainstream track processor only to show the audio level. So you can try it in Chrome so that you can compare the native with the, so one uses a native and the other one uses a shim, so that you can compare both. And this version has like on average, like a 300% increase in CPU consumption and 50% increase in memory consumption. So the problem here is obviously this performance hit, which is unacceptable for some applications. In terms of additional developer feedback for the processor, we have Zoom that the issue said that we are currently using a SynTrack processor for video and web audio for audio. It works, but there's a lot of complexity that comes with web audio and shared array buffer, and also handling the case when shared array buffer is not available. They say having a SynTrack processor for audio would certainly simplify things. That's Zoom. And there is this other developer who develops a lot of interesting tools for audio. So it has this project called MediaBounty.dev. And he says that I'm actually shocked to learn that the SynTrack processor doesn't support audio processing. So I've been using it for years with other projects, and then he's moving to support Safari, and then it only supports video. Yeah. And he likes it because it says the SynTrack processor for audio is perfect because it meshes extremely nicely with web codecs, and I guess he's going to experiment with using the audio worklet. And well, that's it for Media SynTrack processors. The conclusion for Media SynTrack processor is that the shim does support the processing use case, but it has a non-trivial cost in performance, and makes it difficult to support the timestamps. Now let's go to Media SynTrack generator. So for Media SynTrack generator, what the polyfill does is that it uses message passing to pass samples from the worker to the worklet. You have a queue in the worklet, and basically you're filling that queue in the worklet, and the worklet reads from the queue, and that fits a media SynTrack sourced from the audio context. So the approach is similar to the processor shim, but the difference with media SynTrack processor is that the media SynTrack processor internally does that too. It has a queue before the stream, but the SynTrack generator doesn't have a queue and doesn't need the queue. It just gets the data and can push it immediately. So the worklet just pulls from the queue, like I said, and the problem with this is that it doesn't adequately support the processing use cases. So this is the shim. We tested it with processing demo. The demo, there are the links. It's basically a demo that does pass through processing, but every couple of seconds it adds a time to make the processing longer, which is like the use case for this. And the performance is really terrible. It's you get super high latency and audible glitches every time there is a delay in the processing, and there's no way to recover from that because the worklet pulls data on a schedule, not on demand. So it's not able to catch up when processing becomes fast again. So this is a graph that tries to explain what happens. So the processing is highly variable. Some processing runs are long, but most of the time is fast enough. So the generator sends data as soon as processed because it sends data on demand, whereas the worklet sends data on a schedule. So if when it tries to pull data, the processing hasn't finished, it will send data anyway, and then it will send glitches. And then once processing becomes fast, it stays at that pace and it doesn't really recover. And that works like really bad. It's basically unusable for of this type, which is used the main use case to do it on the sender side. So the problem is the worklet is not designed for faster than real-time processing, and this is a use case that is average real-time processing, but some parts might be slower and some parts might be faster than real-time. That's the use case for media stream track generator. So with a worklet, you need a buffer before the audio worklet. And the issues are the ones that I just mentioned. If processing is slow, then the workload will output glitches and the delay will accumulate. And the only way to make this usable is if you have a much more advanced intermediate buffer in front of the audio worklet that can, for example, accelerate the audio. So you need to implement something like NetEQ in this intermediate buffer before the worklet. If you want to recover, to catch up when processing resumes to be fast, if you want to do it without doing it with glitches. Of course, this is still a suboptimal solution because you still have a buffer between the processor and the generator. And so you're still adding more delay. And of course, that's likely to have an non-trivial cost in CPU and complexity. So basically the trade-off on the processing for the sender side, which is the main use case here, is that with media stream track processor and media stream track generator, you have a trade-off between the maximum queue size that is in front of the processor, and it's very easy to avoid glitches with a large enough buffer, with a large enough maximum queue size. And it recovers very easily from processing delays because you are sending data as fast as it's produced. With the worklet, you have a trade-off between delay and glitches, depending on how big you want the buffer. And this is a buffer that is between the processor and the generator. So it's in addition to the buffer that is in front of the processor. And you have a trade-off between how big that buffer is and the glitches. And it's a very difficult trade-off because in many cases, unless you have something super advanced, you are going to have both latency and glitches whenever there are processing delays. So the conclusion is that the media stream track generator is good for processing that is real-time on average, but with high variance. It tolerates a slow processing of some samples, so it catches up quickly with different samples that are processed quickly. It can preserve timestamps and metadata, and it's a very good choice for center-side processing. It's usually bad for receiver-side processing because there you require rendering, and then on real-time priority scheduling can introduce glitches. So you shouldn't use it if you want to render the audio with the output of with the worklet is it's good if you have it has the low latency requirements, so you need to use it. It runs on a real-time schedule, and it's good if the processing is guaranteed to complete before the deadline. And it's bad for high variance processing, and that's the case whether it's it doesn't matter if it's in the sender or the receiver. It's very difficult to keep latency low without glitches, and it's difficult to avoid glitches in general. It doesn't preserve timestamps or metadata, but it's good if you have to render audio. It's the only solution if you have to render audio because the real-time priority prevents glitches due to thread scheduling. So the conclusion is that unlike what we initially thought, the need for mini-string track generator for audio is much greater than the need for the mini-string track processor, because the Shinfor mini-string track processor works for the processing use case at a cost, but it works. But the mini-string track generation shim is completely unusable. So here are the links, and yeah, so feel free to try it. I had some graphs. Oh yeah, here are some graphs of how it looks. So this demo just adds a little bit of latency at 3 seconds, 6 seconds, and 9 seconds, and then you see how the latency increases with the shim every time. Whereas with the generator, it increases when it's low, but then it catches up and the latency goes down. So yeah, that's it. We still have a few minutes to discuss this. Glenn?
Thanks for the presentation and the effort to prototype. I think that for MediaStream track processor, we could improve a little bit performances by using bilateral streams. But in any case, I still think that some browsers may have perf penalty, and I can understand that web developers might want something simpler. So I don't see a big drawback of exposing audio from MediaStream track audio like we are doing for video frames, basically. I think it's the point you're making about Zoom, for instance, and it's quite natural. You know, like you're getting audio data, you encode them, you send them. That seems quite natural, and having a nice API that provides that immediately is quite nice. Related to MediaStream track generator, what I understand is that MediaStream track generator is useful for when it's for HTTP connection as a sink, but it's useless or harmful when you use it, when you use media recorder as a sink, when you're using web audio as a sink, or when you're using audio or video element as a sink. So the fact that it's useful for peer connection, but potentially harmful or a food gun for other things, make me think that there's an issue. There's an issue which is I want to send this audio through peer connection, and I want to do a transform, like to clarify audio or something, and we should look into that. But I'm not sure MediaStream track generator is the right place for that. So I would like to discuss this first. What's your position with the various things, and whether my description of the use case, whether it's correct or not.
It's using peer connection as a sink, or any other thing that you encode with web codecs and send to the network using some other API for the network. So so it's bad for audio rendering. Yeah. For what Zoom does.
If you're doing like Zoom does, meaning that you have a track and you have like networking and you're using audio codecs in between, then what's the point of having a video track generator in between?
No. Yeah, you don't need the generator. Yeah, you don't need the
Okay.
generator. You don't need the generator. Yeah. You would need it if you had some system that accepted raw audio and did like some WASM thing that would do all that, for example. But the opposite is true for the workload. The workload is harmful to use for peer connection. I mean, you just have to run the demo, and it's super terrible, super terrible, and it's harmful there. So you shouldn't use it there. You should use and the thing is that there's no good alternative for that use case, and it's an important use case. It's audio processing on the sender side.
Yeah, I can see that. I think it's interesting, and we should not limit ourselves to just media stream track generator. And maybe we should also ask the audio working group what their thoughts are specifically to that use case, how they think a system should be designed specifically for that. Because maybe they will have thoughts, maybe they don't have. Because, for instance, you could say that audio worklet is harmful because it's running in the real-time clock and very quickly. But we have the off the context. There's another audio context, offline audio context.
Yeah.
So maybe they could design something else. You know,
the proposal is they have a proposal that is basically media stream track processor for offline audio context. But the things that are offline audio context, we don't have integration with a stream track.
Yeah. Okay. So I think it's worth exploring this issue on its own, specifically mentioning media stream track and peer connection in between a transform, and discussing it here and discussing it with the audio force as well.
Jennifer.
Yes, thank you very much for doing these writing these tests and doing these measurements. I understand they're measured in Chrome, is that right?
Well, the demo for the media stream track generator using the shim runs on all browsers. So there's one that runs on all browsers, and there is one that uses the native one too that only on Chrome. So the ones that need the native one obviously run only on Chrome, but the ones that use the shim run on all browsers.
Okay, so I think we would definitely want to have a look at that and get back to you. I would like to test those in Firefox and Safari. And also, unfortunately, Paul couldn't join today. But I got some feedback from him that on the audio worklet slide, it does not preserve timestamps metadata. He suggests filing an issue on audio worklet for that. That does seem to be a gap that we would like to fill. And other than that, I think our position right now, I think we need more time to look at the measurement results to make a decision here from our end. So thank you.
Harold?
It's quite natural for the worklets not to have a timestamp because it's synchronous. I mean, you just look at the clock, and it advances by this many milliseconds every millisecond.
And also,
in the case where you get lag, and where the time you're processing is not the time you're generating, then you have all the issues that you showed here.
Yeah, because you don't deal with all the data there. You deal with a rendering quantum, which is not. I mean, an audio sample with a metadata and capture time doesn't match one-to-one to the quantum in the audio worklet. So you of course everything is multiple of everything, and the sizes match exactly. Maybe you could map everything correctly, but there could be some situation in which a quantum actually corresponds to two samples with two different capture times. But run it. It runs equally horribly on all three browsers using the shim. So give it a try, and then we can continue the discussion. But at least it's well, the purpose was to present the feedback on all these things and all these measurements as a follow-up to feedback. Yeah.
Great, thank you very much.
So is there an action item on you, Yanivar, to provide feedback on the GitHub issue once you have made your study.
Yes. Do we have the GitHub issue in the slides?
Mm.
Which one is it?
Yes, it's issue 29.
29. Yes.
Good. I guess that's we're done for today.
Yeah, and let's enjoy the Christmas break that is coming soon as well.
So yeah.
Thank you.
Bye-bye.
Thank you, everyone.
Thank you.
Yes. Bye bye.
Happy New Year.
Bye.